Hey, we made it. Happy April 1st. My beard is getting out of control. That's all I can see right now. Ooh, I did score some paper towels. Couldn't find any toilet paper. Just gonna say, hey, we're there. We're on day 8 of our distance learning. It's gonna be all right.
It's gonna be all right. It's gonna be all right.
Getting through this. Big congratulations. That first batch of Khan Academies that were due on Friday. Over 90% of them got done. So that's all 82 kids. That's pretty good.
That's pretty good. That's pretty good.
You guys are doing a great job. Keep it up. Some of you, I'm not going to mention any names, complained that there were too many on Monday. So I think I gave you 10 today. But only 3 exercises and like 7 videos. The videos are good for review. Watch them, watch them, watch them. The last 2 exercise clumps, they each have a video that goes with them. I strongly urge you to watch those. It's new, it's tricky. I could try to explain it. I think the Khan Academy video does a great job of that. So watch it and understand, try to understand what they're doing and why. And if you have to use the hints, use the hints. I'm not going to dock anyone points if you have to do it more than once. Go for a hunt, go for a hunt, go for 100. Try to get 100 on this stuff so you know it. This is now on you. Be accountable. Be accountable. Be accountable. This stuff will show up. As Sal Khan mentions in 1, why do we do this? Well, it's going to show up in physics or chemistry or college algebra. So it's not completely unrelated or useless.
It's not completely unrelated or useless. It's not completely unrelated or useless.
So it is April 1st. No joke. You guys are doing an awesome job.
You guys are doing an awesome job. You guys are doing an awesome job.
I'm going to give you a few notes here in just a second on some review of some things, but otherwise watch the videos. Keep working on those exercises. It's great to see some of you. It was good seeing who has some good news to share. Keep it up. Spread positivity.
Spread positivity. Spread positivity.
But we will get through this. It'll be okay. Just keep it up. If you have questions, you need something, I'm on Zoom. I'm going to leave you a few notes here, a review of some stuff that should help you, and you're going to get to see some.
All right. Welcome here, Mr. Haas's art class. It's a beautiful sunny day. That's a tree. That right here, that's a tree. This may bring back some memories. I don't know, good or bad. That's a tree. Those are leaves growing on my tree branch. So a bird or squirrel will be perched on there. Obviously, there's a hole, an owl or something lives in this tree. It's a house for someone. They're currently staying inside like we all should be, even though it's a bright sunny day and every sun should always be smiling. Okay, so again, here's what I want to review. We're talking about exponents, especially rational exponents. So we took notes on this. We drew this tree because the tree serves as my base. And so we know that our base is B. Right? Pretty simple. The base is the letter B. But we can do some things to that base. I can raise that base to a power. And so the base, which being my tree, it gets its power, its growth from the sun, those rays. So the power comes from up here. Now, the base also gets nutrients, things that it absorbs up through the soil, and it uses those, and this is where the drawing sometimes takes a turn for the worse. But let's see here if I can just do it kind of like this. Oh, it's not as bad. It's not the octopus tree we might have seen in class. Again, those are our roots. And they have all the little, and this is what's going to be bad, right? The roots dig in, and then grow out and expand as the tree grows. So there's my roots. They also source, but those sources of power, nutrients come from down below the ground. So that ground line kind of being my division bar, especially in my exponent. So I have my base, powers above, the roots from below. And so we have some examples here. Let's say, easy example, be something like, and I'll use numbers here this time, is 2 to the 2/3 power. So exponent rules tell us a couple things. My black is dying, so I'm going to jump to blue. So exponent rules tell us that I can write this as 2 to the 1/3 power to the 2nd power. 2 to the 1/3 power is the same thing as the cube root. Now this blue wants to diagonal as well. The cube root of 2 all squared. So I need to know that there are a couple different ways to write these things with my powers and my roots. So remember the tree, we know that numerator in the exponent is the power. That's when I multiply something over and over and over by itself. This would be 2 squared, so 2 times 2, 2 times. And the root is down below in that denominator of the exponent. And that's when I have to take something apart, where what multiplies by itself over and over to get to, well, there's no nice easy number multiplied by itself 3 times. It gives me 2. Instead, we look at some of our perfect cubes, which we can look at in our notes, or we can, again, just cube things, figure out what they are, or even use a calculator to cube root things if they are perfect cubes. So this is your quick little review. Mr. Haas's art class, bringing you the base with a power root and how we can rewrite these things. The only other thing I'll point out is that this last way I wrote it, you could also write this as the cube root of 2 squared. And so those are all equivalent. And as you go through some of your things, use your exponent rules. Khan Academies will go back into detail about which ones you're using and help you with that. Use those. Use this to help you. Have a great day.